and I don't get to teach it very often, so I'm a touch bit rusty on this one. So if I don't make sense, it's mostly because I don't know what I'm talking about. But it's based on this. Okay, one must understand, if I asked you to measure a line, okay, one must understand that if I asked you to measure a line and you measured this out, and let's say it was, I'll just pick a random number, 8.9 centimeters, even though that's longer than that. Okay, that is probably not going to be an exact measurement. Okay, because it's only as exact as the measuring device that I'm using is. In other words, it could be that this line actually ends up being 8.90053 or whatever, but my ruler that I'm using doesn't have, what is this, tens, hundreds, thousands, 10,000s or 100,000 sign. Okay? So this really, even though it looks like an exact thing, is more or less, and it's not really an estimate, okay, but it's only close. It's not a perfect measurement. And I don't know if you could, when you measure something, you probably could never, ever really get perfect, because a ruler you could keep using could be cut into smaller and smaller increments as you go on. Okay, and for that reason, mathematicians come up with this concept of significant digits. In other words, when you're using measurements, things that you measure, okay, you can only be so close as the measurement that you've been given. Okay, which means this. Let's see. This, because it has an 8 and a 9, that has 2 significant digits. In math, if I were to take this, if I were to take 8.9 and multiply it by, let's say half, multiply it by 0.5, okay, what would I get there if I multiply that? If I cut that line in half, I get 5 times 9 is, work with me, 45. 5 times 8 is 40, plus 4 is 4. Where does the decimal go?
2 and 4.45.
Okay, now, here is where the problem comes in there. Okay, my measuring device that I used only went to tenths, but if I cut this in half and multiply by 0.5, my answer ends up being in hundredths. Okay, and that is a little misleading because I didn't measure this in hundredths, and yet the answer I got was in hundredths. You're not allowed to do that. Okay, you can only use as many significant digits as you are given in your least or most significant thing. And I'll talk about a little bit more later. In other words, really, you have to cut this off and say, I can't count this 5.
Round it up.
Okay, I don't even know if you round, I have to look and see. Okay, my answer can only have 2 significant digits in it. It can't have 3 because my measuring thing that I used didn't have 3 significant digits, and it only gets that close. That's kind of the gist of the whole significant digits. But there's a whole bunch of rules, Zach, if you're listening and following along, that you use with that. And write these down. Okay, when you are looking for significant digits, when you deal with significant digits, okay, when you're counting them, here are the simple little rules, and they're kind of logical. Number 1, you count all non-zero digits. Count all non-zero digits. Number 2, and there's about 6 of them here, you do count zeros between non-zero digits. I suppose we should do some examples here. Okay, for example, well, for the first one, if you had the number 2.54. 2.54, how many significant digits? 3. You count everything that's not a 0, for sure. Okay, this one here, 1.07, how many significant digits? Still 3. Because there are, you count the zeros that are between not zero things. This would be 3. This, 1.070, 3. Don't count ones at the end that aren't sandwiched between non-zero things. Okay. Step 3. Welcome to the wonderful world of a little higher level math. 3. Sorry. It's actually, that last one should have been 4, because step 3 says you do count. You count trailing zeros in decimals. Sorry. Well, this one actually would be 4. I told you I'm not this actually does equal 4. Oh wait. Yeah. Number 4, do not count zeros if there's not a non-zero digit to the left. Do not count zeros. You can tell zeros are going to be a problem here, aren't they?
Yeah.
So, do not count zeros if there is not a non-zero digit to the left. If there is not a non-zero digit to the left. Now by that it means this. If you have this number here, 0.023, you only count the 2 and the 3 because this says in order to count a 0 there has to be a non-zero digit to the left. Okay, so this only has 2 significant digits. Okay, if there would have been a 1 over here, actually if there would have been a 1 here, what would have happened? You'd count 1, 2, 3, 4, 5. But no 1, you don't count. You only count those 2 digits there. Only in a couple more. We'll do some examples. Decimal doesn't count. What?
So the decimal doesn't matter.
Nope. Not in this case, no. Oh, good. I don't like rule number 5. Can I skip it? Well, here's what it says. Trailing zeros of whole numbers are ambiguous.
That sounds confusing, skip it.
Number of significant digits in 1200 might be 2, 3, or 4.
Alright.
It's
Yeah,
expressing-
pass
We'll come
or
back to that
pass?
one.
Pass.
Number, well, let's put 5 here. Now this is what might throw you for the exact numbers have an unlimited number of significant digits, so you don't count any digits when dealing with exact numbers. Okay. In other words, this. If it is exact numbers, you don't count significant digits. Okay. In other words, when you talk about feet to yards, if there's 3 feet in a yard, if you're talking about this 3, you don't count that as a significant digit because it's an exact number. You know that there are exactly 3 feet in 1 yard. There's not going to be 3.00005 feet a yard. It's an exact number. Usually you think about this in terms of when you're measuring something with some sort of a measuring device. That's where significant digits come in. 5,280 feet in a mile, you don't count significant digits. Significants don't matter because there are exactly 5,280. It's only when you have numbers that could be, when you measure how many miles with a ruler, then you got to count the significant digits. Things that you're actually measuring, that you could measure on a scale that could be more exact or less precise. If it's an exact thing, 60 minutes in an hour, you don't look at the 60 and go, there's 2 significant digits or 1 significant digit because there are exactly that. You don't even worry about it with that. Taylor.
So like if it's already like a.
If
like
it's
a
something
formula.
exact that you know for sure,
Yeah, so like if it's an already formula, like 3 feet equals 1 yard,
Yes.
you don't do anything.
you don't worry about significant digits there. It's only when you're talking about, like I said, you're measuring a line, you know, if somebody's saying, I don't know, how many cups of flour, 2.5 cups of flour, because that is something you can measure. 16.9 fluid ounces, I don't know if they could get that exact there. Okay, so here's what we need. Here are the rules then, some rules that you need to follow. What's that? Well, those were the rules for how many significant digits you're counting. This is the rules and how they get used. Okay. A product or quotient, a product or quotient, that means if you're doing a multiplication problem or a division problem, a product or quotient of two measurements may only have as many significant digits as the measurement with the least number of significant digits. This will all become crystal clear in just a second. With the least amount of significant digits. Give you a chance to write that down, and then we will shoot down a problem there. How many of you feel good about significant digits right now? Look at one of you. Okay,
Besides that.
here's the deal. So, okay, let's say here is a line that you measured. Okay, you have measured the line and it is it is, 8.9 whatever, 8.9 inches long, 8.9 centimeters long. Okay, I am going to divide it by 4 into 4 equal parts. Okay, before you do the problem, here's the question you have to ask yourself. Okay, how many of those numbers am I using are exact numbers, or how many of them are a measurement sort of thing that could be measured and cut into smaller pieces? The number 4, I'm cutting into 4 equal parts. That is an exact number, it's not a measurement. Okay, I'm splitting into 4 equal parts. So you don't worry about significant digits with that. This is a measurement though. Okay, which meant had I had a ruler maybe that had thousands or whatever, and I could have got more specific or more exact with it. How many, since this is a measurement, how many significant digits are there? 2. Okay, that means in my answer, I am only allowed to have 2 significant digits. When I do this problem, my answer can only have 2, like we had those rules of what are significant digits, I can only get 2 of those digits in my answer. So when I do this, if I divide 4 into 8.9, 4 goes into 8 twice, 4 goes into 9 twice, 4 goes into 10 twice, 4 goes into 20 that many times. I am not allowed to have that as my answer. If I did that right, did I do that right? Okay, because it has more significant digits. It looks like it's much more exact than the answer I really could get because I only measured out to the tenths. So my answer is only allowed to have 2 significant digits in it.
Round it.
I don't know if it says you round. Does it say you round? Wait, let me see. Yeah, you have to round to 2 significant digits. It doesn't matter in this case, but the only answer I'm allowed to have is 2.2 because I can only have 2 significant digits in it. I forget all about this stuff. If this would have been a 5, I'd have rounded it to 3, but 2.2 is the answer to that.
Okay, and like,
Okay, another one.
so you can round, yes, got it, okay.
Here's another one. The volume of a cube, with edges that are 1.2 millimeters long. .2 millimeters long. Okay. What do you do for volume? You have to, well, first of all, if you draw on the cube, this is 1.2 by 1.2 by 1.2. Is 1.2 a measurement?
Yeah.
Yes. Could it have been more exact had you had a more exact ruler? Yes. So this, okay, to find volume, you're going to multiply 1.2 by 1.2 by 1.2, okay, but you're only allowed to have how many significant digits in your answer? 2. So you sit down and you do the math. 1.2 times 1.2, that's what, 144, times 1.2 is what, 288, and 144, 8, 12, 7, is that right?
I don't know.
17.2.
I don't have a calculator with me.
Okay, if I get 1.728 as my answer, I'm only allowed to have 2 significant digits in it because in my factors, you can only use the one that has the least amount of significant digits, which is 2. So my answer to this would have to be what? 1.7. And that is all that you could do with that.
I got.
Now, one more rule. A sum or difference means if you add or subtract, a sum or difference may show no more decimal places than the measurement with the fewest number of decimal places. May show no more decimal places than the measurement with the fewest decimal places. Which makes a lot of sense if you think about it, doesn't it?
Totally.
For the volume thing that you did on the cube, can you read that?
Can I what?
Can you read that, please?
Not right now, I can't. Right in the middle of this sum or difference problem. You don't know how I got 1.2 times 1.2 times 1.2?
I was just wondering how to do the decimal thing.
Oh, I what?
Do the decimal thing.
The decimal thing.
The,
The multiplication?
no, the first one. How you, how the significant digits.
Yeah, we'll come back to that in a second. So this means this, people. This one you don't really look at significant digits because it's kind of a thing there. But if you had 2 sticks, let's say you were measured, I don't know why you want to do this, let's say you were measuring how long something was put together. If you measured one stick to be 1.5 inches, and then measured the next one to be 1.934 inches, if you were adding those together, you add this together and you end up with this. Okay, you can't have that because, you see, science is a very exact sort of thing, or math when you get into this here. If you told this to the guy, okay, you gave this measurement to somebody, he might think that you measured both of them out to the thousandths place, which you didn't. This one you only measured out to the tenths place. So in your answer, you can only be as exact as this one that has the fewest number of decimal places. Otherwise, he's gonna think your answer is much closer than it really could have been. Because this could have been, had you had something better to measure with, it could have been 1.508, which would give you a different answer here. But it wasn't, you only measured out to the tenths here. So when you do this and do it and give your answer, it can only be to the tenths place. For the simple reason of you can't end up with an answer that's more exact than what you started with. So when you do this, they're saying you can only be as exact as the one with the fewest decimal places. This only had one decimal place, so your answer is only allowed one decimal place. Again, the basic gist is you can't get an answer more exact than what you started with, which is what you would need somebody to believe there. Isn't that very much exciting? Now, Kendall, your question back here, what's your question? You understand how I got this? I multiplied the three numbers together, 1.2 times 1.2 times 1.2. That's math, right? We shouldn't have to get you into that. You look at these, and each one of these have two significant digits. In your answer, you're only allowed to have as many significant digits as the factor that has the least amount of significant digits. Well, they all have 2, so the least amount of significant digits they have is 2. So in my answer, I can't have 4, which is what this is. I can only have 2, which would be 1.7. I can smell something burning. Is it your brain mostly?
Yeah.
Like I said, I only remember doing this once in all of my mathematical career. Ashley?
Let's say you have like a decimal, like 1.19, would you round it like 1.1 or 1.2?
Well, if you would round it if you're only allowed to have two significant digits. Yes, if you're only allowed to do that. For the simple fact, you know that this one that's at least that exact. I mean, you know that since that's 100, you know that you're going to be able to get closer to that 1.2 than the 1.1. So, let me give you a problem here. If I gave you this problem here, right, straight out of practice, 16.4, and again, this is dealing with measurements, people. 16.4 meters divided by 1.2 seconds. And I asked you to do this problem. Since those are both measurements,
Wait, is that a 5?
seconds. Meters, seconds. If I asked you to do that problem for me, and tell me what your answer should be. Do that problem, tell me what your answer should be. Out.
Wait, it goes into 8.
What's that? Wait, it's not 8, is it? What is it?
6,
3,
72.
1, 12, 44, 3 is 36. 80. Wait, what?
It's 13.6.
Now, what should your answer be? I'm going to tell you what the book is, and I'm going to tell you I don't really know for sure. I know where they come up with the first ones, but I don't know. I don't know why they didn't. The answer is 13.
Yes!
But the question is, your answer can only have 2 significant digits because this only has 2 significant digits. But the question is, why didn't they round it? Because they said to round before, but they don't say to round here.
Maybe they don't like rounding.
Cause it's a repeater, so you don't round.
No, repeaters have nothing to do with it.
Well, then they just don't like that.
Yeah. I'll look that up there.